Flack, Flack math.
Oh, I didn't see you there. I know what you're thinking. You're thinking, Mr. Flack, when are we going to learn about subscript variables? Well, today's the day. Lesson 79, here we go. Our objective today, solving systems of equations with subscripted variables. So, subscripted variables are just normal variables, but they have little subscripts on the bottom of them. So for example, if I wanted to compare two distances, I would have d of 1 equals d of 2. So instead of choosing a different letter like C and D for two different distances, I want to use D for distance. So since distance equals rate times time, we can say distance of 1 is R1 T1, and distance of 2, wait for it, is R2 T2. Because it's like Star Wars. Okay, so example 1. Let's just try it. So we're not going to worry about putting together these equations. In this lesson, we're just going to talk about how to solve a system of equations with these already in place. So your examples are going to start with a master equation. So in this example, it's RATA plus RPTP, it's fun to say, equals 320. All right, but this is 4 different variables. It's 2 different R variables and 2 different T variables. But you have to think of them as 4 different variables. So we can't solve an equation with 4 variables in it. So luckily, they give us these variables. R of P equals 50. T of P equals 4. And T of A equals 3. So our mission is to try to solve for R of A. Okay, so what we're going to do is we're going to rewrite this equation with its substituted values. R of A we don't know, that's what we're solving for, so R of A equals R of A. T of A they give us is 3 plus R of P, which is 50, times T of P, which is 4. That equals 320. All we did was rewrite this equation. So let's simplify. First step to solving the equations is simplify both sides separately. So that's what we're doing. We're just cleaning it up. Okay. Both sides are simplified. Second step is if you have variables on both sides, get rid of the smaller one. We don't. So step 3 is get rid of the constant term on the variable side. So to get rid of a term, you either add or subtract it. Since this is being added, we subtract it. All right, last step in solving equations is divide by variable's coefficient. Why do we divide? Because it's being multiplied. So to get rid of stuff, you have to do the opposite. So R of A equals 40. Example 1, done. All right, let's move on to example 2. Now this is going to be a little different. It always is with Saxon. They just push you, they keep pushing and pushing. They're relentless. So, the directions here say solve for T of R and T of T. Okay, here's our master equation. This is the equation that we're going to rewrite with its substituted values. Okay, here's some substituted values. R of T equals 2. R of R equals 10. And T of T doesn't equal a number, but it equals another variable. That's okay. So we're just going to take that guy and we're going to replace it right. Oops, that didn't work. Right there. Okay. So let's put these values in where they go. So R of T equals 2. So we're going to rewrite R of T as 2. And T of T now equals T of R. Plus 120 equals R of R, which is 10 times T of R. So it doesn't tell us what T of R is. Well, it kind of does, but if we replace t of r with t of t, then we would have an equation with two variables in it, which we can't solve. So we're just going to leave it, t of r. All right, simplify both sides, just clean it up a little bit. So we're going to rewrite it like this. So both sides are simplified. Second step of solving equations is get rid of the smaller variable term if you have variables on both sides, and you do. So get rid of 2t of r from both sides. So 120 equals 8t of r. Last step to solving equations is divide by variable's coefficient. So t of r equals 15. Now you know what t of r is, but we need to know what t of t is. Well, where do you find that out? Well, that tells you what t of t is right here. T of t is whatever t of r is, which is 15. All we did was replace it right there. Okay? All right, moving on. Example 3. All right, so directions say solve for t of L and t of S. All right, aren't you excited to see what this equation is going to be? Like, where's the t of L and t of S going to be? Because it's exciting. All right, so r of L, t of L equals r of S, t of S. So let's see what values it gives us. R of L equals 40. R of S equals 80. And t of S doesn't equal a number. It doesn't equal a variable. It equals an expression. Look at this. T of L minus 5. Well, that's okay. This doesn't change the rules of substitution. So this TL minus 5 is still going to be substituted in right there, okay? So let's rewrite our master equation. R of L equals 40. T of L we don't have, so we're going to rewrite it. R of S equals 80. T of S equals TL minus 5. So if you just write TL minus 5 there, so see how 80 is only being multiplied by t of L. We want to multiply 80 times all of t of S. So all of t of S is this. So to do that, we need parentheses to say 80. You're going to multiply by everything in there. So we're going to do that. First step, simplify both sides of the equation. Just rewrite that. The enemy of simplifying is parentheses. So to get rid of parentheses, you distribute. So 80 times t of L and 80 times negative 5. So 80 t of L. When you multiply a number times a variable, you just squish it together. 80 times negative 5 is negative 400. So minus 400. Okay, both sides simplified. Second step, get rid of smaller variable term. If there's variable terms on both sides, there is. So boom, you're gone. 0 is left on the left side. 40 t of L minus 400 on this side. Okay, ooh, just got a little messy, sorry. All right, we're gonna add 400 to both sides. Get rid of the constant term on the variable side. So a shortcut is, if you want to move a term to the other side, you just negate it. So negative 400 over here becomes positive 400 over here. My handwriting is getting worse, sorry. Okay, last step, divide by variable's coefficient. So t of L equals 10. So t of L equals 10. Well, we also need t of S. Well, what tells you what t of S is? Right here. Literally says t of S is whatever t of L is, which is 10 minus 5. So t of S equals 5. All right, good job. All right, we're gonna do one more example, and you guys are gonna press pause after I write it out. You're gonna try it yourself first, and you press play, and then we'll see if you get it right. Okay, so here's example 4. We're gonna solve for R of F and R of E. Here's our master equation. RFTF equals RETE. T of F equals 16. T of E equals 12. And R of E equals R of F plus 15. All right. So press pause and try this example. Here we go. I'm rewriting this equation. R of F. We don't get R of F, so we're going to leave it. T of F is 16. R of E is this expression, R of F, plus 15. All of the expressions, so we're going to include it all in parentheses, times T of E, which is 12. All right, first step to simplifying or to solving equations is simplify both sides separately. So RF times 16 is just a variable times a number. So we're just going to reverse that and write it the way we like it with the number first. Then we're going to distribute. Enemy of simplifying is parentheses. So get rid of the parentheses by distributing by 12 times RF, which is just 12 RF. And 12 times 15 is 180. Okay, second step, get rid of the smaller variable term. That's my dog barking. Boom, 4R of F equals 180. Okay. Last step, solving equations is divide by variable's coefficient, divide by 4, R of F equals 45. All right, so if R of F equals 45, we also need R of E. So R of E tells you what it is right here. So R of E equals whatever R of F is plus 15. So R of E equals 60. Boom. All right, that's it. So hopefully you know how to use subscripted variables. That was the objective. I hope it worked. I mean, that's kind of my job. So if you have questions, you can message me, or I guess you could leave a comment, but then the world will see your comment, and that's kind of weird. But anyway, thanks for joining today. Yeah, stay tuned for lesson 80.